Welcome to episode 251 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm all right, Rob. How are you doing?
I am doing fine. Don't think I have really too much news to share myself. You?
No. Like all the public things are on hold, basically, right? So
Yeah, nothing's really changed on that side.
I
Go
will
ahead.
share something that's moderately interesting.
Mm-hmm.
Because we talk about the meetup on our podcast, and apparently someone, my meetup, the Denver meetup, someone mentioned my meetup at the Munich C++ meetup the other day. And then we had, in our last meetup, which we're doing via Zoom, we had like a couple of people from Germany and someone from England. Now, keep in mind, we start at 6 p.m. Denver time.
So it's like midnight or something for them, right?
We're starting at midnight. No.
If not later.
Yes. We're starting at 2 a.m. and we had people from Europe joining us. And they stayed not only for the talk, but also for like an hour of the happy hour after that. I was impressed.
Yeah.
Something. Yes. It was like 4 o'clock in the morning when they were getting off. And then we also had someone from Taiwan, somewhere where it was like 7 o'clock in the morning for him when we started.
Wow.
So we're like, hey, who are you? So he pulls over. He was apparently driving, pulls over on the side of the road and like turns on the video on his phone so we can like chat with him for a minute.
Well, that's pretty
cool.
cool.
The last time I thought about C++ at 4 a.m.
Right.
Okay. Well, at the top of the episode, I'd like to read a piece of feedback. We got this long email. I'm not going to read the whole thing, but it's, hello, thanks for the C++ Center podcast. Very appreciated. I mostly listen to it while ironing my clothes. I would like to make a suggestion for episode 300, which is, full years away, but we appreciate the suggestion. Instead of the usual suspects, Bjarne, Herb, or Andre, I'd like you to invite Andrew Koenig, who worked with Bjarne at Bell Labs and did a lot of work kind of in the early days of C++ at Bell Labs. I don't think I've heard his name before, but yeah, I Googled him, and he definitely has done a lot of great work for C++. So I should see if he's still active and might be interested in coming on.
I have heard the name before, but no, I wouldn't be able to give you a lot of details.
Yeah.
That name is famous for the lookup, right? Isn't that?
Is that right?
Koenig lookup.
Oh, that's the rules for argument-dependent lookup, right?
Yeah, I think so.
Yeah, that sounds right.
That would definitely be a good suggestion then. I don't know if we want to wait a whole 50 more episodes to have him on, but I will start looking into it. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Ben Smith. Ben is a software engineer at Google on the WebAssembly team, as well as the chair of the WebAssembly working group. Ben, welcome to the show.
Hi, thanks. Yeah, glad to be here.
Ben, I believe you win the award for the shortest bio that Rob has ever read.
I like to keep it short and sweet, I guess. Mostly I can't think of anything else to say, so.
Well, I get that. Sometimes you're stuck between too little or too much when you're working on your bio.
Maybe we could ask how long you've been working on WebAssembly and what did you do at Google before then? Because it is like fairly recent project over the last 5 or 6 years, right?
Yeah, that's right. Yeah, so I've been basically working on WebAssembly since, I guess not exactly the beginning, but basically the beginning, 2015. Although we didn't really have a WebAssembly team then. So yeah, for about 5 years. And I've been at Google since 2011, so before that. But before that, I was working on Native Client, which is a sort of similar-ish technology. It was about running C++ in the browser in Chrome by using a sandboxing technology. So, and then before that, I used to work on video games, but that feels like very ancient history now.
Any games that we would recognize?
Maybe. I did a brief period where I was at Blizzard, where I was working
Oh.
on the game that became Overwatch. But at the time, it was a very different game. So I worked for 2 years on Overwatch before it was Overwatch. So I don't know if that gives me some kind of cred.
Do you ever wish you were back in the game development world?
You know, I really do love games. I still play them quite a bit. There are things about that I really like. Actually, one of the things I really love about the game industry is that you work with a lot of different types of people. So you work with artists, you work with musicians, you work with designers, and that may be less common when you work in sort of straight tech. So I do miss that. But yeah, I like working at Google. It's pretty great here. So
That's cool.
Very cool. Okay, well, Ben, we got a couple news articles to discuss. Feel free to comment on any of these, and then we'll start talking more about your work in WebAssembly, okay?
sure.
All right, so this first one is a library update, which is Tumul for modern C++, which in its version 1.30, I don't think we've talked about this library before. And I'll be honest, I've interacted with Tumul files somewhat recently because the tool we use to generate the CppCast website has a Tumul configuration file, but that's my only familiarity with it. I don't know too much about Tumul. It seems like kind of a fancy INI file format. I'm wondering, if you know more about this, since you're probably more hooked into web technologies than we are.
I don't know a whole lot about this format other than that it's the format used for like Rust, right? For cargo.
Oh, is it?
Yeah.
Okay.
I spent a couple minutes staring at this going, why am I supposed to care? Why am I supposed to... Oh, right. I've been learning Rust recently. Yeah.
But yeah, otherwise I don't know much about it. I mean, I think it's supposed to be friendlier than JSON, which isn't very good for this sort of thing, and friendlier than INI. But yeah, I'm not super tuned into this format for sure.
Well, one thing that stood out to me is the project has a JSON outputter. So if you have any reason to go back and forth with some other tool that doesn't have Tumul support, then you've got that. Which, it seems like there are definitely all those cases where you're like, well, let's see, I've got this configuration data and the other thing uses YAML, but this thing uses JSON. So I don't know, at least we have the parts to connect them together.
Yeah, I mean, they're all basically doing the same thing, right?
Mm-hmm.
All right. Next thing we have is an article on Kate Gregory's blog, and it's a pretty long post, but I thought it was a good one, and it was how to ask for C++ coding help. And it's basically Kate's thoughts on, having people approach her in online communities and how to go about asking help the right way. Definitely some good stuff. She points to Stack Overflow as a pretty good community for requesting help.
I am bookmarking this article. I am using it when I get questions for help from people because it's more than just, oh, you could ask Stack Overflow. It's all these like, don't paste a screenshot of your code. Send us a Godbolt link or a Wandbox link. Right. Like, oh my goodness, the number of people like on C++ Reddit that paste screenshots of what they're trying to do, that is very difficult to give help when people do that. Yeah.
Makes sense.
It's a good article.
Yeah.
I really...
Okay.
Yeah. I thought it was pretty interesting too, for sure. I definitely saw sort of similarities to when I was working with students last year. It's very helpful to have them ask in the right way, although it's different when it's like in person versus online.
Right.
Okay, next thing we have is an update on talks and speakers at the CPP on C talk, and this is pretty good. They are now going to have Herb Sutter and Walter Brown as keynotes, which is pretty cool. And this conference is moving fully online, right, Jason?
Yeah. Yeah, it's fully online. The tickets are available now. I think where's the price? Either one of you have it off the top of your head.
I do not.
Full online conference, £125. So way cheaper than an in-person conference would be.
Right. They're still doing the workshops too, if you're interested in those, looks like.
They are still doing the workshops, yeah.
Yeah.
Yeah, I read through some of the topics. It looked like there's some good stuff. I'm pretty interested in C++20 stuff for sure. So, and ranges always sounds cool, although I haven't used them yet.
That's approximately where I am with ranges too.
Yeah.
I'm tempted to sign up, even though the time zones would be all wrong, mostly just to see how this goes, the fully online conference.
Yeah, are they still going to split it up into different tracks with, multiple tracks giving their, talks at the same time? Or could you actually maybe see more of the content in an online format, I wonder?
I have no idea.
Yeah, be curious to see.
Well, at least you won't have to be too late to the room and miss getting a seat.
Yeah. Okay. And then, Jason, you put one more link here about a Reddit discussion about what IDEs C++ developers are using.
I thought it was apropos because someone had just asked me on Twitter at approximately the same time what my favorite IDE was. So I retweeted it, and there's been a large Twitter discussion about that. And simultaneously, but I think they were two different people, someone posted to Reddit asking what IDE do you use? And there's just a ton of info in here. I'm not even going to go through any of it. A lot of it's usual suspects for like C Lion and stuff, but there are people who use Emacs, whatever that's about.
Ben, what's your tool of choice these days?
I used to use Visual Studio back in the day. It was very, very common in the game industry. And then as soon as I came to Google, they kind of were like, okay, well, you have to pick your side. Are you Vim or Emacs? And I was like, well, I don't know. I've never used either one. And so I just sort of randomly chose Vim, and I've been a zealot ever since.
So I actually, when I first started programming in C++, my mentor was using Emacs. And I was faced with this decision, like, oh no, I have to choose one, right? And I realized that VI, some version of VI, is required as part of the Unix standard. It's going to be on any Unix system. And I'm like, well, there's my answer. I need to learn how to use VI. So now that's my official answer. If anyone asks me why I chose it, it's because it was purely pragmatic. So
well, and the keyboard shortcuts show up everywhere, right? Like if you use Gmail, the JK navigation is built in, and even in GitHub, actually, they use JK navigation. That's just like Vim.
Right.
So
I don't. Huh.
Didn't know that. Okay. Well, Ben, as we mentioned already, or as you mentioned when we were talking about your bio, WebAssembly's been around since about 2015, or at least that's when it maybe started coming out. I think around that time we had JF Bastion on when it was, a very early proposal. What's the state of WebAssembly today, though?
yeah, that's a great question. So actually, I did a little digging, and I found that you chatted about WebAssembly in 2018 as well.
Yeah, we had Damien Boole on a while ago.
Right. Yeah, and so those are actually kind of two interesting points, right? So 2015 was when it basically started. There was nothing, and then there was WebAssembly. But I'm guessing by the time that JF was chatting with you, it was still not really fully formed. We didn't ship in browsers until about 2017. Okay. And then by 2018, people were sort of like, okay, what is this thing? Seems kind of cool, but there wasn't a whole lot of usage yet. Now I think what we're seeing is a lot of excitement about it. So some of the big news stories were that last year in December, we had the version 1 standard become an official standard, a W3 standard. So you can look at the spec now up on w3.org, and that has 140 pages of beautiful, beautiful spec text that you can read, all the details. But since then, we've also had a few new proposals merged in. So we have a proposal process for adding features to WebAssembly. It's modeled after the TC39 process of JavaScript. So it works similarly to that. And the idea is that as features sort of progress through the standard, eventually they're standardized. They get to phase 5, and then they get merged into the spec. And then occasionally we will push that spec up to the W3 as well. And so we've already had 3 new proposals added in. They're pretty minor things, but we're hoping to have some bigger features added in soon as well. So the features happen to be sign extension. So we have some new instructions for sign extension. Seems pretty minor, but they can be useful. Non-trapping float to int, which is actually an interesting mismatch between C++ and WebAssembly. So the idea here is when you convert from a float to an int, we originally had the behavior that if the float was out of range, it would trap, basically halt WebAssembly execution. And it turns out that LLVM-generated code that ends up being tricky because they sort of expect, based on most hardware architectures, that when you convert, it does sort of a best effort instead of trapping. So then they have to do an initial check beforehand to prevent it. Anyway, so sort of delving into the details here, but adding a non-trapping version of that conversion means that now we can have faster execution for that common operation.
Although there's definitely people listening to this podcast who would find that interesting, just for the record, so feel free to go into the weeds on some of those things.
Okay, excellent. And then another one that we implemented was MultiValue. And so that's another interesting case, if I can get into little details.
Sure.
So WebAssembly is a stack machine. And so certain things about a stack machine make it very easy to handle multiple values, right? Normally, programming languages, you accept multiple parameters and you return one result. You might return multiple results as a tuple or something. But in a stack-based language, it's actually very convenient to just leave extra values on the stack, right? Mm-hmm. And then that's how you would handle multiple returns. And so WebAssembly was sort of already set up for this. And it turns out that that actually is beneficial in a number of ways for, say in C++, if you want to have a struct returned on the stack, you could actually return multiple values instead of having to write into memory and then read back out. So we can actually lower to a more efficient form in WebAssembly. So that's kind of a cool, useful feature that we've recently added as well. So that's kind of the current status inside the sort of core of WebAssembly, which is what I focus on. But then outside of WebAssembly, there's a lot of stuff going on too. So originally we focused WebAssembly on this idea of being a web-based execution engine, right? It's just sort of like alongside JavaScript, it's another place you can run code. But it turns out that a lot of the design that we did around WebAssembly makes it very useful for a lot of other environments as well. So if you think of something like Lua, why are there so few languages that are so nice to embed inside of other environments? Lua is probably the most common one. And I think WebAssembly sort of fills a similar role, but as a VM, where it's very easy to embed because we designed it as being an embeddable VM, right? It's designed to be embedded inside the web platform. And so for any other platform that wants to have a portable execution environment, WebAssembly is a really great choice, right? So what we see is that if you are running, say, code on the blockchain, you care about very similar things, right? You care about the security, you care about non-determinism. And so rather than defining your own environment, you can you can use WebAssembly as a basis. And then the security properties that we care about for the web also matter for WebAssembly. So if you care about those security properties running natively, then WebAssembly is a good choice. So anyway, that's sort of the sum of the state. I don't know if you have some questions.
No, I am finding myself extraordinarily curious at the moment of just how easy it is to write a WebAssembly VM then. So like, do there currently exist very easy to use portable embeddable VMs that you're recommending people use? Or are you saying, well, it's so easy to embed, you can just slap together your own VM real quick?
I mean, so yes and yes, actually. There are some really great ones, and also it's kind of a fun, I mean, at least in my opinion, weekend or multiple weekend project to create your own. In fact, there's a great talk by, I'm going to forget his name now. I think it's Dan Beasley, where he implemented a WebAssembly engine during his talk in Python. And took some code that was compiled by Rust to WebAssembly that was like a little spaceship shooter game, and got it working by the end of the talk. So it's not too hard to get working. The number of instructions is pretty low. I think it's like 80 total, but most programs don't use them all. And yeah, so you can do it yourself. I've actually written a WebAssembly interpreter that we maintain and people use. But realistically, you're going to want to use one of the professional ones. And there's actually quite a few of those too. They're basically in all the web browsers. But then also there are some standalone versions like Wasmer and Wasmtime and Wasm3 and Wavum. Anyway, they all start with Was, so they're going to be hard to distinguish. But yeah, there's quite a few of them, and they all have sort of different properties depending on what kind of things you want out of a WebAssembly engine.
So just now to go backward, though, if people are interested in at least understanding the spec or writing their own interpreter, how do you find that information? Yeah,
so some people kind of like to do this like you're writing an emulator or something. And so in that case, you can just pull up the spec and go to town. It's a little bit tricky. I've heard that the spec is hard to read. It's actually very mathematical. It's been formally verified, so it works. But
oh,
wow. But yeah, it can be pretty dense. Actually, if you're really curious about floating point semantics, WebAssembly, as far as I know, has some of the most sort of formalized semantics of the IEEE floating point math. So if you want to look at the execution semantics there, they're pretty cool. But yeah, the spec is a good place, but also you could just look at some of the tests that we have. You can also sort of cheat and use some existing interpreters. And then there's some sort of like easier documents. So back when we were designing WebAssembly, we had a document called on GitHub called WebAssembly/design. That was the design repo. And if you look at the semantics and binary format documents there, they have some of the sort of early documents that we were using that are sort of simpler to read. They're not up to date. We haven't been keeping them up to date, but they are some good opportunities to, get your feet wet writing some WebAssembly.
I'm sorry, it does sound like it would be a lot of fun. So I won't dwell on it too much, but it's interesting that you said that the spec has been formally verified. We had someone on talking about formal verification techniques, a couple of years ago, Rob? Something like
it's
that?
been a while.
I'm really curious, if you know what tools were used, or was there tools used, or how that process went?
Yeah, I do know, and I'm going to be embarrassed to forget the details.
Yeah, I just sprung this on you, so.
Yeah, so it was, so Andreas Rosberg is the editor of the spec, and I believe he was working with Conrad Watt of, again, a university that I'm going to forget in the UK. Anyway, yeah, no, I probably should have been more prepared for this, but I believe he was the one who was working on the formal verification. I can probably pull it up if I look real quick, but.
Conrad Watt is at Cambridge.
Yep. Okay, that sounds right. And yeah,
so he has articles about WebAssembly and verification.
Yeah. So that would be it.
Okay. I'll put a link to that in the show notes if listeners are interested in reading more about it.
Yeah, that's probably the best way.
Yeah.
So
yeah, I don't remember the tool.
Okay. That's fine. Yeah. Like I said, I just sprung it on you. So.
So you gave a CppCon talk last year where you went over a lot of this, and I should definitely encourage listeners to go and watch your talk if you haven't already. And one of the things you talked briefly about there that I don't think we talked about with either Damien or JF is the WebAssembly system interface. I was wondering if you could tell us a little bit about that.
Yeah, I think I I was sort of throwing a lot of content into that CppCon talk because I was like, 90 minutes, how am I going to fill this? And so, yeah, I think I probably glossed over a lot of things. But yeah, WASI, WebAssembly System Interface, is sort of this new design. So like I was saying earlier, WebAssembly itself is this sort of container, right? You can import functionality from the outside, and then you can export functionality back out. And then it has everything else that's sort of encapsulated, right? There's memory that you can write to, there's variables you can store and so on, and functions you can implement. But otherwise, it can't really do anything. If you think about it, it's very, like I said, very similar to Lua, right? Lua doesn't have a lot of built-in functionality. And so if you actually want to do anything, then you need to have some API on the outside that actually provides you that functionality. Mm-hmm. And so WebAssembly is the same way. And normally, or sort of originally, what we said is, well, just come up with your own. It's fine. That's sort of the whole point here. But at some point, people say, well, if we're running in a non-web environment, there's certain things that I expect to have, like mostly people want to be able to do, a printf or a cout or something, right? So having some kind of well-defined interface is important there. So that's what WASI is it's a standardized interface that's meant to be used by WebAssembly applications for common POSIX type stuff. So opening and reading files, directories, sockets, random numbers, and so on. And so then the idea is that as we move forward, we can start to add new features to that as well. So crypto and graphics and sounds and so on. But starting off, it's going to be sort of the thin stuff that you would expect from 1970s computer.
So if I, at the moment, were to use the C++ standard library with WebAssembly and ask for a crypto device, we just talked with Martin about this, right? Like a couple of weeks ago. Would I then be getting actually this crypto device that is hooked in through the system API thing?
Yeah, so it's a little bit tricky because depending on the type of WebAssembly you use, you might get something different.
Okay.
So WebAssembly on the web is going to use the web APIs because WebAssembly, that's part of the reason WebAssembly doesn't have any built-in functionality. It's because we expected that people would always just use web APIs. So web already has a crypto interface. It's called web crypto. And so you can access that directly by calling through JavaScript. But on the non-web environment, there's not really anything there. So having a unified interface is what you would use. And I think they're still working on it, but yeah, you would get some suite of APIs and some data structures that would go along with that will allow you to, say, get random bytes, and then, or use, certain encryption schemes, that kind of thing.
So when I implement my own WebAssembly interpreter, I'm going to need to implement these system calls for myself because the system interface will be expecting them.
Yes. Again, sort of depending on the WebAssembly.
Right.
So yeah, I think I've seen that you have done some emulator stuff before. Yeah.
I have, but let's not pretend like I really know what I'm doing. It's just something that is fun for me every now and then.
Yeah, so one of the cool things about WebAssembly and one of the hard things too is that if you just take a random WebAssembly file, there's a good chance that you won't be able to run it 100%, right? Because it'll say, I'm importing things like GL graphics. And so you'll have to sort of know what they expect from that. The WebAssembly interface is hoping to make that more unified, but for now, it's very common that people will compile using Emscripten, which is a C++ to WebAssembly compiler. And so that has its own set of APIs that will have different behaviors. So if you know what the JavaScript is going to do, then you can implement it yourself in your WebAssembly interpreter. But the hope is that eventually we'll get to a place where there's just the spec and you say, yep, here's the functionality I need, and then you implement that. So what will happen right now is you'll take a WebAssembly file that you're interested in running, and then you'll hit some import, and you're like, well, what does this do? And then you have to go and figure it out, just like if you're writing an emulator.
Right. So like right now, my emulator can only play Tetris, but
Right.
next week it'll be playing Super Mario Brothers.
Exactly.
And we just had people ask us to cover more emulator talk, Rob. So I'll
Yeah.
just phrase the rest of the questions in this interview in context of that.
Yeah, so actually I wrote a Game Boy emulator in WebAssembly, so
Oh,
I'm definitely happy to talk about emulator stuff.
So have you been able to run it on your own WebAssembly interpreter that you are maintaining?
You
That is
know, I
full.
never I know this sounds dumb, but I never even thought to do that.
That's like full end to end, right? Like, yeah, you've got to try that. Let us know how it works.
Yeah, no, that's a good point. I really should try that.
So did you write when you say you wrote your Game Boy emulator in this WebAssembly, did you actually hand code it in WebAssembly or did you use Rust or C++ or something and then compile?
Yeah, so I used C actually
Okay.
because I was on a bit of a C kick at the time, and it actually turns out that it compiles really, really well to WebAssembly. You can actually set up like extern functions, and there's better ways to do this now, but if you just call out to an extern function, then when you compile the module, it'll sort of say, well, I don't know what this is, so I'm assuming that you'll fill it in later. And then you fill it in with a JavaScript function. And then when you call out, it just calls to whatever JavaScript functionality you need, like drawing pixels or so on. So you get this nice sort of capsule of code, and then you just sort of wire it up to the web browser and it's ready to go. But like I said, it's way easier to do nowadays. I think you can actually embed JavaScript directly in your C++, and then the compiler will sort of extract it for you and then wire it up. So
Wow.
there's some cool stuff. And then actually Rust allows you to do the same thing, but that's, I guess, for a different podcast.
Since you mentioned other languages, we can just briefly talk about this. I think JF said that C++ was kind of the first language that WebAssembly was built for, but is any compiled language, capable of writing to WebAssembly or targeting WebAssembly?
I won't go so far as to say any compiled language, but definitely that's a goal, is to support as many languages as we can. So C++ was sort of our starting language just because we were like, well, this is a use case that we know we already have. People are currently compiling C++ to JavaScript, which is what was happening at the time. And
Scripting.
And yeah, exactly. And one of the issues we were having is that as JavaScript VM implementers, we had to deal with this really bizarre code, right? This code that no one would write by hand. So WebAssembly was meant to be a way to say, okay, instead of doing this, which is sort of a roundabout way, why don't you compile to something that we want you to compile to? And now we can sort of deal with that. So that was the reason we started with C++. But then because we were using LLVM as a backend, then most languages that use LLVM to generate their native code could also use LLVM to generate WebAssembly. So that means we get, I won't say for free, but Rust support comes along for the ride, as well as things like Zig can compile to WebAssembly, if you've heard of that.
Zig.
I've not heard of that one.
It's kind of an interesting newish language, but also languages like Go doesn't use LLVM, but that's been coming along. Some people have put some effort into that. There's a language called AssemblyScript, which isn't a language sort of before WebAssembly, but was developed to be sort of like a TypeScript-like language that compiles to WebAssembly. Some people have been working on OCaml engines and on Haskell implementations and C#. So actually one really common case is, or one thing we've been seeing a lot of is this product called Blazor from Microsoft that actually is meant to be sort of a full environment where you can take C# and compile that, and then also sort of create web apps using sort of your normal Visual Studio tools. So yeah, we're starting to see a lot more languages compiled to WebAssembly. They're still not necessarily fully featured, but they're coming along. Yeah, and I think as WebAssembly gets more functionality, the number of languages we're going to be able to support will increase.
I'm now also curious, since you said it's designed for embedding and whatever. And you just mentioned all these languages that are starting to support it. If there's a language hobbyist that says, okay, I'm making my own toy language and I want to actually compile it, would you recommend that compiling to WebAssembly would be a good exercise instead of into native machine hardware?
I think it would be an interesting exercise for sure. Yeah.
Okay.
So WebAssembly is a little weird compared to most native targets. So the biggest difference, and I think the thing we get the most complaints about, is that WebAssembly requires structured control flow. So we don't have just go-tos in WebAssembly, and that was by design. And so instead what we have is two different types of instruction. We have a loop instruction where there's a loop at the top and a branch. And whenever you branch to that loop, you go to the top. So it's basically a backwards branch. And then we have a block instruction, which branches to the end. So that's a forward branch. And so you have to actually nest all your code. And that has some nice properties. But what that also means is that if you're used to being able to just drop in a go-to, you won't be able to do that. And that can be tricky for some environments. But there are tools to make that a little bit easier. A lot of people use this tool called Binarian, which is I think it was a play on the name Targaryen, the Game of Thrones. Yeah.
Okay.
Right. And but anyway, the point of that tool is that it's got a number of WebAssembly features. One of which is that you can write sort of normal code that has branches, and it will convert it into a blocky format. The feature is called relooping, so it basically turns those things into loops.
I don't know. It kind of sounds like it takes some of the fun out of it, though, because half of the fun in like writing assembly language or something is, working within the restrictions of that processor. And well,
yeah, no, I agree with you. But if you're just trying to support something, maybe you don't want to, go on a deep dive into
right.
intricacies of WebAssembly.
Okay. I also found it interesting because I've recently been reviewing BASIC just out of my own, because it's like the first 5 programming languages that I used were BASIC dialects. And what you just described sounds like it's perfectly structured for a BASIC interpreter, because you have a for and then a next, which jumps you back up to the top. And otherwise, you don't have very complicated control flow. Now, most BASIC interpreters would have Go too, but you could just leave that out of your version of BASIC and just roll with it.
Yeah, you could. And actually, we see a lot of that where people, there's sort of two choices, right? The easy choice is to write an interpreter that runs on WebAssembly, right? So it actually reads the instructions of your language and then implements those in WebAssembly. And that has the drawback of being slow. And so then the next thing that usually people do is they take that code and then they actually try and generate WebAssembly instructions. So what you're describing is more like a basic compiler for WebAssembly. But yeah, it shouldn't be too hard to do. Too hard.
I'll just add all this to the next, on top of my 15 projects that I'm already working on. And
Okay, so you mentioned that there's, a WebAssembly working group that you're the chair of. Do you know much about or can you tell us much about what the future of WebAssembly is, like upcoming features we might be able to expect?
Yeah, so there's a bunch of new stuff that we're working on now that I'm really excited about. One of the biggest ones is actually connected to what we just talked about, which is garbage collection, which is supporting new languages. So right now we have essentially what we call sort of the linear memory model, which maps very well to things like C++. So the idea is you basically get this big block of memory and you just write data in and you read data out. And the big block of memory is just bytes. It means nothing to WebAssembly. It's all entirely user control, right? But that doesn't actually work very well for languages like, any sort of language with a garbage collector, because what they want is sort of managed objects. And so what they end up doing a lot of times now is they implement their own garbage collector in that memory space, right? So you walk over the memory and then you know which things are exist and you free them or whatever. The problem with that is that it's slow. because you sort of have to re-implement a lot of functionality that already exists. And another problem with that is that because WebAssembly is meant to be embedded inside of something else, often the host has its own idea of objects that you want to have communicate with WebAssembly. And so now you have this sort of cross GC problem, right? If I'm holding onto a host object and the host object is holding onto one of my objects, and then that object is holding onto a host object and so on, now you have this sort of, how do I collect across GCs, garbage collectors? So the idea of the GC proposal is to sort of hand the responsibility of garbage collecting over to the host and say, you deal with it. So I'm going to ask you to create an object and then you deal with the lifetimes. And here's this sort of shape of it. So that's something that we've been working on for a long time. And as you can imagine, would be very hard to support in a language like WebAssembly because we want it to be so generic and support a lot of different programming languages. But yeah, I think we're making good progress there. Some other exciting features are SIMD. So that's actually very, very close. You can already use that in some browsers if you flip a flag, and soon we'll probably have that on the open web. And people are very excited about that because that means now you can take your WebAssembly program and do all sorts of video processing, audio processing, and so on. And so that's a pretty exciting feature for a lot of people. The tricky part there, again, is sort of finding the right subset of instructions that map very well to various native architectures, because the whole point is that we don't want to provide functionality that would be complicated to map to SSE, right, for example. Threads already sort of exists on the web, so you can already use threads in WebAssembly, but it's sort of limited, so it would be great to see some progress there. So that's some future of WebAssembly. And then interop is another sort of big case that we want to work on. So right now, WebAssembly can talk to JavaScript, and it sort of works, but it's a little bit of a hard line because right now WebAssembly only knows about numbers. It knows about integers and floats. And JavaScript has this sort of full suite of ways it wants to communicate, right? Objects and strings and arrays and so on. And so we want to come up with a way to have it so that WebAssembly knows how to communicate with the host in sort of a more expressive way. And so we have a feature called interface types, which is we're working on, that allows you to sort of express these higher concepts inside of WebAssembly. So those are some of the things that sort of features that we're adding to WebAssembly. But ultimately, the future, I think, for WebAssembly is WebAssembly everywhere. I guess that's kind of my manifesto, is sort of like WebAssembly, I think, is sort of universally interesting. There's a lot of different places you can use it. And what I want to see is that people start using it everywhere where it's possible. Anywhere you need portable execution, anywhere you need a secure environment to run, anywhere you want to embed some code. If you were thinking, I want to embed this programming language, well, why embed one programming language when you can embed a VM that allows you to embed a lot of different programming languages? So, and then on the flip side, if I want to run an application and I want it to work on the web, well, why not use WebAssembly? Like, it should be the obvious choice. So that's the place where I want to get to, is where WebAssembly sort of exists on the server, on the client, IoT, everywhere.
Are you starting to see much movement in that space? Like, are you starting to see web developers become more interested in WebAssembly as an option on top of, JavaScript, which has been their default for a long time, I guess?
A little bit, yeah. I think it's still new. I mean, the web moves kind of slow. And also, there's a lot of things that JavaScript is just better at, If you're making your standard sort of web app, JavaScript is a great language for it. I think what happens is you start to hit the seams, the places where JavaScript stops being as powerful, or it doesn't do exactly what you want, or maybe there's a little performance concern there, and that's where WebAssembly can step in and often bridge the gap. But the place where I think I'd like to get to is where you can write more and more of your application in WebAssembly, and it works. Right. And for some cases, that's actually already possible. Like I said, there's a really awesome Blazor demo where they show off writing your web app in C#. And Rust has some really great tools there too for being able to communicate directly with the web environment fully inside of a Rust program. So yeah, I think we're not seeing it yet, but give it time.
Okay.
I'm definitely seeing this the WebAssembly everywhere that you just mentioned. Like it makes a lot of sense to people that like game developers who need a fast execution environment for their scripts. They could write their scripts in a language like C++ that has awesome optimizers available for it and use that, or they could write it in their own homebrewed scripting engine, like many of them already do or whatever. If someone wrote a Lua compiler that went to WebAssembly, then they could already, like leverage all these things in one place.
Yep.
In the 45 minutes we've been chatting, I feel like I'm on board. Like I said, I don't have the time to explore all these.
So when is the interpreter coming? When I want to see this WebAssembly engine you're making.
I don't know. You said someone did it in a live talk, right?
Yeah.
I feel a challenge to do it on a live stream and see what happens, but I don't know. We'll see.
Yeah.
No promises to anyone.
Take a look. Actually, yeah. So one of the things that I do as sort of a fun little WebAssembly challenge is I've been making these things I call raw WASM. So mostly WASM is meant to be, you start with a source language and you compile it and you end up with some WebAssembly code. But you can write it by hand. It's kind of a pain. And so what I've been doing is writing these tiny little programs in WebAssembly directly and trying to get them as small as possible. So I've made a few things. I made a little Wolfenstein-like maze game, and I made a little ray tracer in like 1,000 bytes or so. And I actually was just working on a chip 8 emulator, and I got that in about 1,000 bytes. So that's a fun little thing that you can sort of take and use that as an example for your WebAssembly engine when you...
Your chip 8 emulator?
Yeah, exactly. Stack all the emulators.
Emulate all the... Okay. I'm just going to do a quick search for that so that it's ready to go. So does anyone written an assembler for WebAssembly then, or are you like handwriting? What does it look like? Is it, I assume it's byte code of some sort.
It is a byte code, yeah. So we have a text format and a binary format. The text format is a little clunky. It's S expressions, and it's hard to write. So for example, anytime you want to refer to a number, like a 32-bit number, you have to actually write out open paren i32.const 0, close paren. And that would be the number 0, because that basically pushes that number onto the stack. So it's very verbose, but there are sort of other formats that are lighter, but they're sort of non-official. The actual text format is pretty hard to write, I have to admit.
Okay.
So we spend a lot of time on this show talking about what's going into the next version of C++, talking to various committee members. As the chair of the WebAssembly group, do you have any thoughts on what C++ could do differently with our standardization, or what we could learn from WebAssembly?
Yeah. So actually, so as far as the process, I don't know. I feel like you all have that down pretty well as far as coming out with new versions. In fact, the whole sort of 3-year cycle thing I think works really well. So I think we probably could have a lot to learn from you all in terms of process. But in terms of some functionality in WebAssembly, some things that we're working on now, we don't really know how to fit it into C++, and so we've been sort of thinking about it. So I mentioned before that WebAssembly has this idea of a block of memory, right? But you don't have just one block of memory. You can actually have 10 blocks of memory individually, and you can index them statically. And there are reasons you might want to do that, right? So imagine that, again, you're in this host environment. I want my block of memory, which is internal for me, and no one else can look at it. But then the host has its block of memory that it gives to me and says, fill in some data. Now I have 2 blocks of memory, right? And those things are independent. And I should know when I'm writing into one and writing into the other. But C++ doesn't really have this concept, right? It's just one big linear block of memory. And not only that, but like anything you hand to C++, you can scribble anywhere, right? I mean, it's undefined behavior, but there's nothing protecting you from sort of scribbling somewhere you shouldn't. And so that's an interesting thing that we're like, well, how would you do that in C++? How would you create an opaque pointer in C++? So that's one thing that we're seeing. And actually sort of on a related point, the host can hand in functionality to me, right? So imagine that you have a web DOM node, right? It represents a text box. You can hand that into WebAssembly, and WebAssembly is going to say, I don't know what this is. It's completely opaque to me. But it can sort of hand it around, and it can put it in and store it somewhere, and then it can hand it back out and say, well, you gave me this thing. Here, have it back. But again, there's no way to do that in C++ as far as I know. To have, I mean, void pointer is about as close as you can get, but even a void pointer, you can sort of mess with, right? So yeah, there's things there that we're not exactly sure how they would map to C++.
Do some of the other languages that can target WebAssembly, are they going to be able to implement these features more easily?
That's a good question. Maybe not. This might be a place where we have to have some sort of future language that knows how to support some of these pieces of functionality. But actually, even MultiValue is a case that maybe doesn't fit super well with C++, right? This idea of returning multiple values. You can kind of do it, like you say, returning a struct or something, but that's more of an ABI concern. So there's questions there. Or even things like, when we add garbage collection, how does that make sense at all for C++? Maybe not. The other languages that could support it, maybe as a secondary tool on top of the language, right? So that language would generate some code, and then a secondary tool would say, well, you said this, but what you meant was this, and convert it into something else that uses this WebAssembly feature. So another one which I'm a little bit curious about, I don't know the specifics of, we've been talking a lot about coroutines in WebAssembly, this idea of being able to sort of pause execution of a WebAssembly thread and then switch to something else. This is really important in the web because everything is asynchronous, right? So we want to be able to sort of pause execution and then fetch a resource from the network and then resume with that resource available. And I know C++20 has support for coroutines, but I'm not sure enough about what kind of coroutine that is to know whether or not the functionality that we're talking about providing, which is actually sort of like a stack switching type of coroutine, is the type of functionality that C++ is suggesting, which I thought might be more of like a program rewriting style coroutine. So that might be another feature.
Yeah, I think it's not the same type of coroutine. I am so fuzzy on these things. But technically, C++ coroutines require a heap. They're saved. They're dynamically allocated things. Although that can go away with LLVM CPollision or Clang CPollision. But yeah.
Okay, so that actually might line up pretty well then.
Okay. I have no idea. It's one of those topics I keep meaning to learn more about.
I mean, the people who are into them are very into them, so I think there must be something there.
Right.
Okay. Well, we've talked a lot about WebAssembly. One more thing I wanted to ask you about that you mentioned in your talk was that you did an intro to C++ class as part of Google in Residence. I was just wondering how that experience was for you teaching intro to C++.
Yeah, it was very interesting. Both of you have taught C++ before, is that right?
Jason teaches C++ to professionals, yeah.
I tried to I try to stick to classes where people already know C++ and I'm helping them refine their skills.
Mm-hmm.
And I could see why that would be beneficial. Yeah, one of the things no, I mean, it was an awesome experience, but C++ is a very hard language to start with. And I can see some of the benefits. It's very nice to be able to sort of talk about things. Like I had an opportunity to talk about floating point representation with these students, which I think kind of blew their minds. I know it would have blown my mind if I was a first-year student. But there are a lot of concepts that I have to sort of hand wave away that are a little too complicated. One thing that I did find, which I really liked about C++, and I don't know that a lot of other languages do this. Let me roll back a second. So we go out as a cohort to a bunch of different schools, right? A bunch of us. And some of the schools, we basically teach whatever the school is already teaching. So I taught C++ because Morehouse teaches C++. But some schools teach Python, some schools teach Java, so on. And so I talked to all of these other professors about what their experience is like. And what I found was that they have to start talking about references and ownership earlier because these languages have this transparent concept of references, right? So if you have an int in Java, that's a value type. But if you have a string, it's a reference type, even though it doesn't look different. And Python's the same way, right? I mean, technically everything is a reference, but some things, it doesn't matter that it's a reference because it's a value, right? And so they have to start explaining this idea of like, well, I said A equals B, and then I changed to A. Why does B change, right? And in C++, you have this nice property, which is if you just skip the ampersand and pointers everywhere, then everything is a value type, mostly, right? Mm-hmm. And so it's kind of this nice thing to be able to just say you're always getting a new copy whenever you use something. And I actually found that to be maybe the only thing that was simpler about C++ than other languages.
Okay. Huh. Very cool. Well, it's been great having you on the show today, Ben.
Yeah, it's been great being here.
Thanks for coming on.
Yeah.